Okay folks, so we're finally back. I've promised you guys an updated version of how to use Unity3D and mlagents package to do your reinforcement learning and custom AI development with the new version 2.0. So let's go ahead and get started, show you guys how that all works. Alright, so first of all, I want to be very clear here about what we're doing. We are using the Unity3D install of 2021.2.3 and we are using the Unity version mlagents 2.0. Okay, so whenever you're using mlagents, versioning is extremely important, and in fact it's taking me a couple months to figure out an appropriate version package. Since mlagents is a rapidly developing platform, this stuff is changing fast and you got to keep up your versions if you're working with new installs. Once you get an install working, you probably want to commit to that, but there is going to be a bit of code that is going to get swapped out as versions continue. So now that we've got our Unity environment loaded up, I just created a brand new 3D environment. The first thing we're going to do is go to this window tab. Then we're going to go to Package Manager. And now we are going to install the mlagents package so that we can use it in the custom environment that we're building. So up here under Packages, in Project, click that drop down menu and go to Unity Registry. Once you're in there, you can search for mlagents, which will pop up, and you can see the default package is 2.0.1. You want to click on that and hit Install. That's going to take a little bit to install, so while that's installing, let's talk about what we're going to do today. Today, we are going to create a very basic first thing you do in the mlagents documents on their GitHub, creating a new learning environment. So if we go over here to our handy dandy internet and we go to mlagents GitHub in whatever search browser, you can get to the mlagents GitHub repository. Once you're there, very important folks, first thing you want to do is click on this drop down main and switch to the 2.0 verified documentation. That's going to give you the correct code to run this tutorial. So if you scroll down, what you'll learn is all about the Unity mlagents toolkit, and you can get to a point that says releases and documentation. Click here to get started with the latest release of mlagents. That's what we're doing today, guys. So we click there, we scroll down, and we see the starting documentation page. So specifically what we're doing is this thing right here, making a new learning environment. So go ahead and click on that. You'll get this very pretty picture. This is what we're making today, guys. So I'm just going to have this up so you guys can see how you might go through this process on your own in case you have a versioning issue and you need to sort it out yourself. But basically, the first thing that we're going to do after we've installed our mlagents 2.0.1, we can exit out of here. Now we're in our Unity window and we want to right click on this hierarchy page and click Add. We're going to add a 3D object called a plane. That's going to be our floor. So if you use your scrolly wheel on your mouse, you can zoom in. And the next thing we're going to add is a cube. So when that cube comes in, we're going to drop it up above the floor and maybe move it over a little bit. Now we can right click again in the hierarchy pane, go to 3D objects and create a sphere. Again, move that up. See, I'm left clicking on my mouse to drag this thing up and down. I'm going to move it over a little bit. And there we go. That's our setup. So in this particular environment, our sphere is our agent and our cube is our target. The goal of this environment in terms of a deep learning agent or reinforcement learning, which is what we're going to use today, is that this ball, this sphere, has to figure out how to roll into that cube. Okay, and it's living on this plane, so if it falls off the plane, it's going to fall off, right? We have to put it back on. So the next thing you want to do is just check and make sure everything's going. your game will load. And what you can see is that our box and our sphere behind the box are floating in midair. So what we need to do is go ahead and turn on gravity. So we're going to turn off our game display by unclicking the pause button. We're going to wait a second till we switch back over to our scene tab. And now the first thing I want to do is change the camera. So when that we're in game mode, we're not looking at that weird angle. So I want to look at the angle I'm looking at now. So I'm going to click on my camera, and I'm going to hit on my keyboard Control-Shift-F. And that is going to set the main camera to the current angle that we're looking at. So the next thing you need to do is we need to embody our sphere with some mlagents scripts. The first thing we need to do is add the rigid body component. So over here in your inspector window, scroll down to add component and click on rigid body. We need to do the same thing for our cube if we don't want it to be floating in midair. So click on the cube in the hierarchy pane or in the scene window. Click on the cube, click add component, again click rigid body. So now you'll see when we click on the game window that these things use gravity, right? Because we have use gravity selected. And so when we do that, now we can use real world physics simulations in here using the rigid body component. So I'm going to unclick the play button, I'm going to click on our sphere, and we're going to get started using the mlagents package. So the first thing we need to do is scroll down, click add component, and type in the search window. You see this teensy tiny search window. We're going to type in new script, okay, and it's just going to pop up here. So we're going to click that. It's going to ask you for a name. Name this whatever you want. I'm going to call this roller ball, and click create and add. Okay, so once that does that, your Unity window is going to reconfigure itself to reload these assembly scripts, and you can see that this rollerball script has been made here in our project window pane. So if you right click that, you can click open containing folder, and that's going to show you where in your computer that script is stored. So now I can right click on this and say open with Atom. And if you haven't noticed by now, I'm using Ubuntu version 20. Okay, so now I got my favorite text editor opening up this script, which is just delightful. And we need to embed our mlagents script into this. So in order to do that, I'm going to use our handy dandy mlagents documents, and I'll provide all this code so you don't have to go through copying and pasting all this stuff. But basically, we're just going to go ahead and use the script they're already using. I'm going to unpack this for you after we get started. But just go ahead and okay, so I'm going to unpack this for you guys after we get it all copied and pasted. Just to make it a little bit easier. So just go ahead and erase everything you have in the script, paste that stuff right back in. So that's the first thing we need. The second thing we need is our collect observations function. So we're just going to copy this, and we are going to go down here and paste this. Oh, I didn't copy the whole thing. So we're going to copy this. We're going to paste this like the wonderful programmers we are. And we notice that it didn't get pasted correctly, so we're going to make sure all our tabs and indents are aligned. And we're going to scroll down here. We're going to copy this one. We're going to paste this one. Programming's so easy, right? Don't you love living in this era where we're not dealing with binary bits? Alright, okay, okie dokie. We can also add this heuristic. That's going to be very important. We're going to talk about that later. Paste that right in. Make sure all our tabs and indents are where they should be. Okay, I'm just double checking that my lines are all where they should be. Some of them are not still. Okay, we are good to go. Just need this closing bracket here. Yeah, we're going to save this file. We can minimize our window here, minimize our window here. And now we're going to reload. Okay, so we've got our first error. It's a good sign. It means the system is working. So just to show you guys what this looks like, okay, when you get an error, you get this little red bar down here. You can switch over to your console tab. You can see that we have somehow forgotten one of these little bracket bars. I normally code in Python, so this is pretty to be expected. We don't have bracket bars in Python. So that's what was missing. This won't be a problem for you guys. You can just copy and paste from the script I provide you. And when we click back into our Unity window, we're going to see that we have major problems and that we probably want to just cry at this point. Alright folks, so after a bit of crying I figured out what the bug was. And this will happen a lot. So this has been kind of the painstaking last couple months of my life, is figuring out these version controls, among many other things, don't worry. And what I found here is that in some of the new documentation on the GitHub, they don't include this actuators component. And so there's multiple ways to do this on action received command. So for a minute, just for some background, whenever you're using mlagents, there are 3 functions you must call. You have to call on episode begin, which will describe how, let's zoom in, which will describe how each episode is to be set up, the starting point for each game. The second function you have to call is collect observations. This is going to provide the state to your reinforcement learning algorithm, or whatever other algorithm that you're using. Collect observations is the state, the information that your agent is getting. The last algorithm, and the trickiest one, is the on action received. Now you can see in here there's action buffers. So in some of the documentation on the mlagents GitHub, they don't use action buffers, right? They use vectors. Either is fine, but if you're going to use the action buffers, you need this little tiny one-liner of code here. Okay, so if anyone's struggling with this, this is the answer right here. If you're getting this, we don't have action buffers answer in your console log on Unity, you probably forgot to add this little bit of script. So in the code I'm going to provide you guys, you should be ready to go, totally Gucci, and we're just going to ignore these warnings and go back to our project. Okay, so we're ready to go. So now what we need to do is we've embodied our sphere with its 3 components. How this scene is going to be set up, what information this sphere is going to collect to give input to its neural network or reinforcement learning, or however you choose to set this up. We're going to use reinforcement learning today. And what action it's supposed to provide you once it processes that information. So we need to tell this sphere how many actions to take, how many decisions it should be making on a regular time period. Okay, so one thing you need to be really careful about is that this name in your script that we just made, this name right here under public class, this word, whatever you put here, has to be the exact same word as the name of this file. Okay, just let's be clear. This word, rollerball, has to be the same word as rollerball. It's very important. Okay, so once we have that, we can add component called behavior parameters. So I've done that step here. We just clicked on here, we typed in behavior parameters, and we clicked add component. We also need to add to our sphere another component called the decision requester. And so the decision requester is going to tell your agent how many decisions it should be taking for each time step, basically. So as it makes decisions, how often should it do this? We're going to bump this up to 10. And under our behavior parameters, we're going to rename our behavior to something fancy, like roll. And our vector observation size and action space is going to have to be changed. So at this point, we need to figure out what the heck we just copied and pasted into our script. So let's go through this. The first thing that you want to do here is notice that we have some imports. So we are going to use the generic system part of Unity, the Unity engine, the Unity mlagents package, sensors from the mlagents package, and actuators, right? So actuators is where this action buffers situation comes into play. Now we've defined our script rollerball under this public class, inheriting the class or the information from agent. Agent is a package in the mlagents repository or in the code that is going to embody our rollerball agent with certain functions. So in order to use our sphere or rollerball as a physical object, we need to import the rigid body component that we added to our agent previously. So we can do that by saying rigid body, which we're going to rename R body for short, or RB, any variable name you want. So let's just keep it rigid body. And we're going to say on start, so void, that we're just speaking to the inner depths of Unity and saying on start, we're going to load up our rigid body component by calling getComponent rigid body. So you see here what's going on is that we're specifying the class or the type for a variable that we're going to use later. And when we use it later, we're actually giving that variable a value. Okay, so the next thing we're going to do is we're going to have something called target. So again here we have a public object. The type of object is a transform, which means we can transform the physical location of this object. And that object is going to be called target. So let's just pause there and go back to our Unity editor. You can see here under the rollerball script, we have this thing called target. Now we can click on this teeny tiny circle with a dot in it, and then we can go here and click on cube, right? But if you didn't want to do that, then what you could have done is clicked on sphere and then dragged your cube into this target. Where'd it go? Oh, yes, this target area. Alright, so now our agent knows, or the script rather, Unity knows that this agent's target is this sphere. So when we go back to our script, whenever we're referencing target, we're referencing the transform of that cube object. So the first function we have to call, as we said, is this onEpisodeBegin. So we're going to publicly override any of other Unity's internal stuff, and we're going to speak into the depths of Unity, and we're going to say on the episode begin, at the beginning of each game, we are going to do the following functions. And so the first thing we want to say is that if our sphere falls off the platform, our platform being our little plane here, then clearly we need to set the sphere back on the platform using magic. And so in order to do that, our magic is going to be say, take the angular velocity, so the rotational spinning of our sphere, set that to 0. Take the regular velocity, so the directional velocity that we're moving in, set that to 0. And move the position of this being our sphere, because this script is attached to our sphere agent, and transform the local position to a new position 0, 0.5, 0. And in order for this to work, we need to say that this information lives in a vector of 3 dimensions. Okay, so that's if our agent falls off. We're going to set it back on the platform. And at the beginning of each episode, we are also going to move the target to a new position to keep this interesting. If it stays in the same spot, it's going to be too easy, right? So we take our target. So we're not saying this. We're saying target, your local position is now going to be this new vector 3 value, which has this random value times a number minus a number to keep it within our plane. the y, so this is the x position. The y position is going to be at 0.5, floating point, and the random value again is going to set our z position. So all of these functions are going to be called every time we start a new episode or a new instance of the game. And so our second most important function that we've already discussed here is that we're going to need to call collect observations to give our agent information to compute that information to provide an actionable decision. So the cube is going to take in sensory data and it's going to output an action. So here again we're saying we have this public override speaking to the depths of Unity, and the type of information this function is going to take in is a vector sensor called sensor, right? And so we can do that because we've imported this sensor class up here. All right. So back down to where we're working, we're going to say our sensor that is bringing in our information, add this observation, so add this information that we want our sphere to have, which is going to be the local position of the target, right? So our target is our cube, so whatever the position of our cube is, add that to the observation. So let's just go down here and talk just for a minute about what local position means. So if you click on your cube and you scroll up in the inspector window, we're talking about this transform. So this position, this 0, 1.3, negative 1.73, if we move this object, you can see that those numbers are changing. So those numbers are essentially what we are going to be giving when we say target local position, right? And so we're also going to add the observation of the sphere's local position, right? So at all times, the sphere is going to know these numbers, these three numbers, and the cube's three numbers for position. And the sphere should also know how fast it's moving, right? So we're going to give the velocity in the x direction and the z direction. So just to be clear, this is the z direction, this is the x direction, and the y direction shouldn't change because we're going to use gravity, which means these things are going to be sitting on this plane unless we fall off the plane, right? Which you should have noticed from this guy up here. Okay, so that's our observations. That's going to be our state vector input to our agent. So we can move on to our last and trickiest function, the on action received. So on action received is going to say, hey, after I get the information and I do some computations with whatever brain architecture I'm using, which in this case will be reinforcement learning, I need to provide some output. And when I get that output, how am I going to transform the reinforcement learning or neural network learning or whatever type of computational engine you're using, how am I going to transform that output into something that matters in the Unity environment? Okay? So what's going to happen is we're going to use this action buffers class. It's way too complicated and annoying to get into the specifics of it, but it's very easy to use. So what we're going to say is that we're going to have a vector, 3, means 3 dimensions for x, y, z, called control signal. It's just a variable. We could have named this anything like yay or whatever. And at first, we're just going to initialize this variable, control signal, as all zeros. So we can just say vector 3, just 0 yourself. And now we're going to say the control signal at the x position, right, is going to be this action buffers in continuous action space in the first dimension, because we're using x, we want to use first dimension, right? And we're going to do the same thing for the z direction, and that is going to be the first action buffer space, so second dimension. Okay, so what we've done in these 3 lines of code is we've allowed for some container to hold information that our reinforcement learning algorithm gives us about which action to take. And we are using what is called continuous actions. Yay! Continuous actions mean that we can take any number, a floating point number, anything, and apply it to affect a behavior for our agent. the alternative is using discrete actions in which we would have to choose do this action. So one example of discrete actions would be move forward, yes or no. Move left, yes or no. So it's binary, and you can have a certain number of branches, and maybe we'll talk about discrete actions in another video. But for now, we're just using continuous actions. So what we're going to do is we're going to say our rigid body, which allows us to use physics on our object, add force. So we're going to have some sort of magical push to our sphere. And that push is going to be in the X and Z direction depending on whatever information we get for our reinforcement learning algorithm. So basically what's happening here, in case this isn't clear, is our reinforcement learning algorithm is going to get information from collect observations as input. It's going to compute that input using its magic reinforcement learning, and it's going to give an output. That output is going to get stored in this action buffer, right? This is node 1, node 2 for anyone who's familiar with artificial intelligence and classic neural network programming. Okay, so our outputs get stored in these action buffers, and in order to use these values, we convert them into this variable called control signal. And our control signal is then going to get multiplied by this force multiplier. So just to show you, our control signal is going to look something like this, right? It's going to be a vector of some number. Maybe we get 0.3. This is always going to be 0. Y is always going to be 0. And our Z dimension, maybe it'll be 0.1, whatever our neural network gives us. Why is this middle component 0? Okay, that's because we had a vector with 3 dimensions. So our control signal after this step would look like this, a vector that looks something like this, right? So I'm using a list, but just imagine these lists are NumPy arrays or vectors or whatever. Okay, so here we would have 0, 0, 0. And after this command here, .x, we're saying this value right here can be whatever we're giving the action buffer from our reinforcement learning network. And Z is going to say this value here is going to inherit whatever information is dumped into this action buffer from our neural network. Okay? So let's just delete those lines because I was just showing you guys how this stuff works. Okay, so our action size should be obvious. 2, right? We're going to select how much force is going in the X direction, how much force is going in the Z direction. We're not moving the Y direction. And this force multiplier is basically a speed. So when we do our body, our rigid body, add force, it's going to be this, what we're doing is we're using our control signal times our force multiplier, and that is going to give our agent a magic push, the ability to push itself in the X or Z direction. Alright, so the other thing you need to specify in your on actions received is your rewards. This is what makes reinforcement learning go round. Okay, so we're going to say that our target, we're going to say that our agent gets a reward when it runs into the target cube, right? And so in order to do that, we need to know when it's run into the cube. So one way we can do that is we can get the distance to the target. So to get the distance, we're going to say that we have this vector 3. It's going to be a distance between the sphere local position and the target local position. So this distance function automatically calculates the distance between these two objects. And we're going to store that in a vector 3 dimension with this variable named distance to target. So if our distance to the target is less than this number, this small floating point number, then we've reached the target. And we can give our agent a reward. So we can say set reward, because we've reached our goal, to 1.0. Alright, just to give you guys a little tidbit here, you can also call this function called add reward, right? And so the difference between add reward and set reward is that set reward is generally used when you finalize the task. right before you call end episode. So end episode will say, hey, good job, Sphere Agent. You did what we wanted you to do. Here's your cookie reward of 1. You beat the game. Start the game over and try again. Okay? But if you want to set intermediate targets, and this is a little bit of a next level tip, you can set add rewards. So you wouldn't want to call end episode. You would just want to say, hey, I want you to get to the target, say 5 times. That's a different goal than what we're doing, right? Say the target is that you have to get this 5 times in a row. And so every time you get the agent, we're going to add a tiny bit of reward. And then once you finally get it 5 times in a row, then we'll go ahead and we'll set your reward to 1 because you did a good job, and we'll end the episode. And you should know that Unity, what they do is the mlagents package configures all of your rewards to be scaled between the 0 to 1. Okay, so whatever values you put in there, I believe they're still doing this. They may have changed it. But I believe they're still scaling everything between 0 and 1. So 1 is the max reward that your agent could receive. Alright, so another thing we need to do is if we fall off the platform after we take an action, we need to end the episode, right? Because if we fall off the platform, there's no way to get back on it, right? If we fall off here, we have to reload because I resaved the script. If our cube falls off, right, falls off the platform, there's no way for this cube to get back on here. So what we're going to have to do is we're going to have to reset the environment, and we can do that by just calling end episode. Okay, so that's it. That's basically our whole script. We could start training right now. But, it's very important if you're going to be testing out a custom learning environment, especially if you're using your own learning architecture, if you're going to use genetic programming, your own neural network, your own reinforcement learning algorithm, you need to test and make sure that your environment works. So in order to do that, we can use this handy dandy function called a heuristic. And so your heuristic is how you can get a human person to play the game instead of having the computer play the game. So we're going to say, okay, we have this public override looking into the depths of Unity called heuristic. It's going to use these action buffers, these same guys up here, right? We're going to use these same guys. But instead of doing this whole control signal with the neural network thing, instead what we want to do is we want to use our own input. So we're going to say the continuous actions out, which are going to go into our action buffers. Actions out, go in our actions buffers. They're going to be these values. So essentially what's happening, just so you guys get the whole picture of how this stuff works, because these are the fundamentals. Once you get these fundamentals, then you can go on creating and exploring and getting really advanced. But if you don't get these fundamentals, it's going to be tough. Alright, so what's happening is that we're giving an input from our keyboard. So our keyboard has something called horizontal and vertical already defined. Where is that defined? We go into our handy-dandy Unity, our handy-dandy Unity environment, go to Edit, Preferences. No. This is all wrong. Not Preferences. We go to File, we go to Build Settings, Player Settings. Then we go to our Input Manager, click on Axes, and see we have something defined here called horizontal. That is going to be the left and right buttons on the keyboard. We also have something called vertical. That's going to be our up and downs. If you want these to be something different, you can just press the button on your keyboard. Now I can make it W and D. But we actually want this, we want this to be up and down. Okay, so if we exit, it automatically saves it. And so that's why when we're in our code, we can just say, hey, input, get the axis called horizontal and vertical, provide that as actions out 0 and actions out 1, which are going to go in these actions out, which are going to go in these action buffers, and these action buffer guys are going to get called on action received, these guys, and they're going to be these values here. So instead of feeding the neural network the action buffers, we have specified the action, what's going to be in the action buffer with our keyboard. Okay? So that's it. That's the whole script, guys. So let's just go ahead and that's the whole script in all its glory. 75 lines of code or less if you took out these spaces. And we're ready to go. Okay, so you should be very happy if you made it to this point. Okay, so now when we click on the scene, it should load up your script after you save it. You want to make sure that you don't have any red errors. So yellow errors mean warning, okay? Red errors mean you can't run your script. You have to fix the red errors. You don't have to fix the yellow ones. So if we go ahead and click on our sphere, we're going to test our environment by using the heuristic. We're going to scroll down to the behavior parameters and click on the behavior type. Behavior type. Change that from default to heuristic only. Okay? Good. Now we can click the play button. And we see that we get an error. So, anybody want to take a guess? I hinted at it earlier. Okay, so what's happened here is that in our sphere, when we set the behavior parameters, we didn't change our vector observation. Remember, we talked about this earlier. How many observations are we taking in? Okay, how do you know? How do you know that? You go to your script, you go down to your collect observations, you look at that, and you say, okay, let me count my observations. I have a local position for my target. That's at X, Y, and Z. I'm counting on my fingers. You can't see here, but I'm doing it. Do it with me. We're going to take in the local position for the sphere agent. That's at X, Y, and Z. We're up to 6 values, right? We're going to take in the X velocity, that's 7, and the Z velocity, that's 8. So we go ahead and we plop in the vector observation space size 8 because we just counted. And now we need to select our actions. So this is the most important part. Your model, the reason we're getting this error is because we haven't specified the correct number. So what did I say we were doing? Continuous actions or discrete actions? Dun, 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 continuous actions. Right. How many continuous actions? We're going to set discrete branches to 0. And we're going to go and count our continuous actions. So on action received, we have 2, tells you here. But we have an X and a Z, which are going to be combined for the add force, right? But we're only giving 2 numbers, the X and the Z. And you know this also because down here we're only giving horizontal and vertical. So now we can go back here, go to our behavior parameters on our sphere agent, and type in the continuous actions 2. Okay, now when we hit play, well, let's just go ahead and save. Now when we hit play, what we will see is that our error went away. Yay! Very good. And now for the moment of truth, when we use our keyboard, look at that. Look at that. I'm controlling the sphere agent with the keyboard. I'm trying to get it to run into the cube. Oh, it just I fell off. I'm not very good at this. Okay, you don't want me playing in EA games for sure. Yeah. But anyways, we know that it's working. And we know that when we reach the target, a new environment sets. When we fall off the platform, a new environment sets. So we are good to go. We are good to start training. So the first thing, you're done. You did your experiment. You're ready to start training your neural network or your reinforcement learning algorithm. Yay. Okay, so in order to do that, the first thing you need to do is save. Okay, save. Save your work, guys, save. And for the magic, now what we can do is open our handy dandy terminal, and we can say, I'm using Conda, so I'm just going to deactivate my Conda package. And if you don't have mlagents installed, you would just pip3 mlagents and run that. But I already have it installed. And if you want to check what version of your installation, you can hit pip3 list and scroll up here to mlagents version 2.6. So this might be a problem because we're using 2.7, but let's just see if we can get away with it. The command we are going to call is going to invoke the mlagents package that we have installed on our local device. We're going to say mlagents-learn, and then we're going to drop in a YAML file. So that YAML file, we can go ahead and get from the wonderful GitHub repository, and I'll provide all this stuff for you guys so you have it just on deck, and we can just call this roller.yaml, save that, and in our YAML file we are going to say for our behavior. So I'm copying from the GitHub, but in fact we named our behavior role. So I need to switch this to role, right? You see what I just did there? We named our behavior role, and so in the roller YAML file, this word right here has to match this word right here. This word right here has to match this word right here. Okay? Unity use names of stuff to call stuff, to be very unofficial in what's going on. So the reinforcement learning algorithm that we are going to use, which is built into the mlagents package, is called PPO, Proximal Policy Optimization. You can learn all about that on the internet. There's tons of stuff. It's state of the art. It's seriously state of the art. We're going to use a batch size of 10, a buffer size of 100, this learning rate, yada yada yada. You can read through all these things. And so if you're ever wondering, hey, what the heck do each of these things do? If you're trying to figure out what these variables do, I don't want to explain that to you guys because Unity has created a very lovely documentation guide. So if you go to the mlagents package on your 2.0 verified and you scroll down until you get to docs, you go to the docs, you scroll down and you find the thing that says training configuration file. Click on that. And so once you're in here, this will give you all the information for all of these keywords, telling you exactly what they do. They recommend what value it should be. They tell you the typical range. So this is where you can play around with your training and your configuration of your reinforcement learning algorithm that's built into mlagents. So I'm not going to go through this right now. Maybe if you guys really want in a later video, we can go through this together. But I think it's really self-explanatory, and they did a beautiful job explaining, which algorithm you're using, whether it's PPO or SAC. Soft Actor Critic is another one. What values you should set this stuff for. And so we're just going to use the default settings that we've listed here. So now we have this roller YAML file. And we need to go into the folder in which this Unity environment is stored. So if you don't know what folder, or wherever you saved your YAML file, really, but if you ever forget what folder that you're living in your Unity environment, you go to your project and you go down to wherever you're working out of, and you can click these three buttons. I'm working on this. This is called test. And you can click show in file browser. and that'll show you where test lives, where this Unity environment lives. And in there, that's where I've saved the roller YAML file. So we get rid of all this stuff. Now we're ready to run this command, mlagents learn, and we're going to say the config file is this roller YAML file, and we have to specify the path. So in Linux, you can just drop that, and Ubuntu, you can just drag and drop that file name, or you can copy and paste that file name. And then the next thing you need to do, let me zoom in for you guys here. Okay, let me zoom in for you guys here so you can actually see what the heck we're doing. We're doing mlagents-learn, the path in quotes to your YAML file that we just made, and then we have to give it a run ID. So we can say --run -id equals roller test, or whatever you want to name it. And since this is a test file, we might need to run it several times. So we can add this command called --force. So --force is going to just overwrite any previous data in case you run this multiple times. I don't recommend this if you're trying to store real outputs, but if you're testing your environment, it can be really useful. So when we hit enter, if everything is working, you will see this screen. If things are not working, you will not see this screen. And I'm sorry, I'll try to help you if you drop it in the comments, but you probably need to start over because you might have missed something. So it tells us all of our versions, and it tells us press the play button in the Unity editor. So we go to our Unity editor and we hit this play button. But before we do that, make sure that your behavior parameter is turned from behavior type to default, because we are not doing the heuristic. Now we don't want to play the game. We want the computer to play the game using the PPO-RL algorithm that's built into Unity. So behavior type, under behavior parameters, set that to default, file save, hit play. Alrighty, so we can see that we've connected our new brain, which is going to have the behavior role, which is on team 0 because we only have one team, and we're going to load up our configure file, and it's running. If we minimize this, we can see that the computer is running our script. It's using proximal policy optimization, reinforcement learning algorithm, to control the sphere ball and try to get it to run into the cube. So every time the ball runs into the cube, it resets the environment. The cube spawns in a new area. The sphere is exactly where it was before, and the sphere has to figure out how to reach the cube. If the sphere falls off the side of the plane, the environment starts over. So this is it, guys. You just did it. Congratulations. You did your first reinforcement learning algorithm, or maybe not first, but maybe first custom environment using mlagents in Unity3D. So if we go back to our terminal and we watch this for a while, we can start to see the rewards print out as our brain becomes smarter and smarter by iterating through this environment and learning how to navigate this environmental space. Okay, so what happens after we finish training is that whatever directory we are working out of, so I was just working out of my home directory, you probably want to be working out of the directory of your project folder. It's going to automatically create this results folder. And in this results folder is going to be a folder called whatever you named the environment. So remember when we called our mlagents learn, we gave the config YAML file and the run ID. So we're looking for a folder with the name of our run ID, and if we go in that, we'll see this role.onyx. If we drag and drop that role.onyx into our project pane, what we can then do is load that up into our behavior parameters as the model, the neural network model. We can then switch the behavior type to inference only and hit play. So what we just did is we trained our neural network model, we trained our brain, and now we imported that brain, our role.onnx file, into the behavior parameters under model, changed the behavior type to inference only. So now we're running a test use case. So we're using what we learned in our reinforcement learning brain in new environments to see how well our model did. And what we can see is that our sphere is very good at finding the cube and reaching it. So that's it, guys. That's the whole thing. I know it was a bit long, but I really wanted to go in depth, and in the next experiments we're just going to build on top of this structure. So once you get your versionings under control, and if you can get this far, then you can go a lot with your imagination the rest of the way. So thanks for watching, and don't forget to like and subscribe.